Hi, thank you very much. As you said, I'm going to talk about hard surface modeling techniques. And as I said, my name is Pedro. I'm from Brazil. Before moving to Poland, I was living in Amazonas, very close to the Amazonas forest, which is very interesting. And I have more than 20 years in 3D industry, jumping from advertising companies and gaming companies, but I always focus in gaming companies, so I could work for gaming industry more like between now 8 and 9 years, almost 10, and focused in hard surface. This is about hard surface techniques because I took me a lot of time to not struggle more in doing hard surface for games. And just to check if you are all in the same page, maybe for some of you guys, it's a little bit basic, but to make everyone on the same page. The basic process for assets in game is you have the hard surface, or the high poly, which has all the details that you want. Then you create the low poly, which is the mesh that's going to be in the game. And then you make all this high poly information into maps that will be applied further in the low poly, okay? Maybe later we can ask some questions about that process. So here I show another picture to explain better. This is the high poly, the low poly that goes to the game, the map that we extract the normal map from the high poly mesh, and then everything together. You can see the low poly, and the maps applied, and the illusion of the details in the low poly mesh, right? Okay, so how do my work start? My art leader, Juan, talks to the game designers, and they have this like weapon idea that fits the game environment and the heroes, etc. And then they become with a concept, with a drawing that I'm going to show you later. And then with this drawing, this illustration, I start my research and modeling work. Okay, this is an example of kind of something that I get from the guys. This is a nail gun. We are working in a zombie post-apocalyptic game. I have a order for you. This is a crossbow, a SMG, shotgun. And then when my work starts, I dig into this research, trying to understand the weapon that they use to be the basic of the weapon. So try to understand the overall shapes, the minor piece. I go very deep in this to understand how they build, how they are connected, because the animator gonna get my mesh, and animate sometimes they want to show all the process. And yeah, that's how deep I go to get the model done. And then, after all many years struggling with hard surface, I have these 3 techniques that are the ones that I use the most daily. Boolean plus retopo, Boolean plus Remesh, and mechanical modeling, that's the one that I started using in a few months ago. Okay, so for the first one, how does this work? So it's like, I have the shape that I want to achieve, then I try to understand the shapes and the forms. So I use the Boolean technique to cut the overall shape and get very quickly to the final shape that I want. So this I explain better. I have the cylinder, which is the overall shape, right? So with this, I can start modeling. I have this. Okay, so I have these 3 pieces that I did to cut the mesh, right? So I have everything in the right place. So I cut the mesh, and very quickly I have the shape. But of course, it's a Boolean result, so the mesh is not good for the final purpose. So after that, I need to retopo, which means redesign the mesh flow so I can get it the proper mesh for the baked result, okay? So this is one example of the concept that I got. And then I check all the concepts, and I realize that this part would be very hard to do in a traditional modeling way. So That's the piece I'm talking about. There is a lot of negatives, volume. It's very hard to do it normally. So I use this technique to get the shape I want, and after that, I got the result. That's the final mesh in the game. The result I get of the baking and the normal maps. This is the final piece in the game. Final mesh. And then another example, this crossbow, which I have this particular piece here that I think is a good example. This is the final piece, the result. And I did this graphic to show you. I did the overall shape. I did the Boolean mesh that I would to cut, and my final result. And I give to show you the process happening, the magic happening. You can see that very quick I have the final mesh. In that stage, I don't bother for the topo, for the mesh, if it's ugly, if I have anygons, triangles, nothing. I just bother to the final piece, so then I can get to the next. Like here, after the Boolean result, I redid the row topology, which takes some time, it's time consuming. The high poly, which just subdivide the mesh, and then the final mesh that goes to the game, and the final piece that we have in the game right now. And the final mesh. For this game, we have like, in case you want to know, like between 10 and 30K triangles for the weapons. Okay, next technique, very similar but different, way less time consuming, Boolean remesh. It's the same, we start the same way, we realize the shape we want, we create the mesh that you want to cut, and then, but this one, I don't waste time retopologizing the mesh. Because I use this, okay, I use Blender, but okay, if you use Max, it's the same. I think Max is called Retopo or something. That automatically it analyzes the mesh and he creates the flow so you can get this nice result without retopology doing the retopo process. Here I show a little bit quick this process. So this is the Boolean result. And then I do the process of remesh, which is enough for me to get the baking process. Just wait a little bit. Okay, that's the result. So this I have the result. And if I add like, in Blender, smooth modifier, if you use Max, you can have relax modifier. I can create the bevel, which is very important for me when baking normal maps, automatically. Just change the amount. So it's very quickly. You don't waste time with retopo process, which for me is very good. It's just the final piece, very quickly in Substance Painter to showing that the bevel quality that you get from the remesh is good enough for the final piece. And this is another good example because in the end of this, I was finishing that weapon, and my art leader asked me to change this piece. And this piece was very different. This one is way more complex than the one I had before. So I had to finish it quickly, so I did this way. Just cut the mesh. Here you can see the geometry quality is very good, but we have no bevel here, so this is not good. But when I remesh, automatically I get the good bevel that I need for the baking process. Here's the final weapon in the game. Final mesh. That one a little bit more than I should, but it's okay. Another example using that one with this little, because these little details is very hard to do in traditional way. So I did the same. I just modeled the piece. I used the array for these anygons and this shape to create this hole, remesh it, and it's done. Here I have the result, and I explain the pros. Fast way to achieve high quality, high poly result. The cons final mesh can be a little heavy. You can see it's heavy. But you don't struggle with that because you know if you take just the Boolean operation result and just subdivide, you're going to get this, and you can't work with that. The final piece. And finally, the last one that took me some time because my father is an industrial design, and every time that I would hear about mechanical modeling software, I was like, no, no, please, no, it's too complex. It's for engineering people, for that kind of thing. But when I saw some artists that I would follow using mechanical modeling softwares for gaming assets, I was like, okay, something's happening, something's changing, so let's give it a shot. So I had how can I have this weapon to do, so I decided to give it a shot. Okay, let's do this weapon in this mechanical software. And with this idea, I bring in this topic that, is that better for Hardsurface? I would say yes. And just to get us in the same page, I put this to show what I call traditional modeling. When I started almost 20 years ago, we would do everything that way. You know, moving vertices, cutting faces, moving edges, that kind of thing. And the approach for mechanical modeling is totally different. You don't deal with that. We just think about solid stuff. You mostly deal with face and solids, which is very different in the beginning. And let's compare like polygonal, traditional, and mechanical modeling to see which one is better. So here I have this, I did with the process that I showed you using Booleans and showing that if you subdivide, that's what you're gonna get. And then I need to retopologize. It took me 8 minutes to get this shape. I wasn't in a hurry, just checking the time. And 15 minutes relaxing, doing the retopo to get the final proper mesh to bake, right? So, okay, it took me 8 plus 15 minutes. So when I used this mechanical modeling, I did everything in 6 minutes. I had a very high quality mesh, and it's already in Blender, so you have no problem exporting to Blender. It's very, very easy, or Max, or Maya, whatever software you use. And these, can you play the first video, please? I just very, very quickly give showing the process of mechanical modeling. So if you don't know, you can feel how different it is. It thinks in a different way. You basically work with 2D shapes, and you turn these 2D shapes into 3D shapes. And if you need to cut something, it's it's like it automatically do the remesh retopo for you. You don't need to worry about that. You can see, like, I want to remove this bottom part, and I just remove it, and it caps automatically. As you can see, just cap the roll. I don't need to worry about that, because he works in a solid thinking way. It's real time, so it's a little bit slow. So you can see I'm creating the circles that would be like I will cut the circle. So you can see that it gets green every time that realize I'm doing the same size. So it's very interesting because it's like you are modeling a live stuff. He kind of understands, see, what you are doing. So it's very easy to do Hardsurface because he thinks in that way. So for example, I want to cut it. I just, okay, I'm going to extrude to cut. So it understands and it resolves the mesh. The next video, please. In the next video, I show you guys how easy it is for this kind of software to bevel without worrying with these holes in this kind of example. Yes, this one, yes. So now that I have the overall shape that I want, I just want to do the bevel. So I can easily add bevel and different size for different edges. It's very easy. I really want to make it real time so you guys can feel that it's very easy to do. To do that kind of thing in a traditional software is almost impossible. I mean, it's impossible. So it's very precise. I can just say what size I want. We're going to do the same for these circles, this bevel. Can you jump to the next video, please? What I want to show in this last video is how easy it is to change the mesh without you worrying for what's going to happen with the mesh. For example, this, I cut it before, but if I want to change the cut for something different, I just have to drag it, because this kind of software has a history. He knows what happened before, so you can do it very easily. I can change everything anytime, and it recalculates without any topology problem. As you can see, the mesh is alive for it. Even if I want to rotate a face, like I'm going to do now, I believe, if I want to change that face here, oh, I'm still playing with this circle. But now I change this face angle, and it recalculates real time the cut that I did before. So yeah, so you can come back to the slide, please. Thank you very much, guys. So it's crazy good for modeling. So here I show you trying to do the same in a traditional way. You can see that the first GIF, it's impossible. The mesh is ruined. And if you try to mimic this in Max or Blender with modifiers, it's going to struggle because it thinks in a polygon way. It's different of the solid thinking. So yeah, Hardsurface modeling is very good if you decide to try mechanical modeling. It's very less time consuming. Okay, this is the final piece. 90% of this weapon I did use this free software for mechanical modeling. Another shot. The mesh in the program. This weapon I did in like as a personal work to test this software because it's a free software, and you know, free software sometimes is very good, sometimes not so good. So I tried, and I did this weapon in 1.5 days, trying to understand this software. And for me, it was like, okay, this is very good. And yeah, that's it, guys. Can you open for questions?
Yes. Thank you very much for the interesting presentation. Guys, now is the time for questions. Are there any questions from the audience? Okay, first one.
Hi. In this tool you present, there's something like a mirror modifier, or you need to, a mirror modifier. So you present that you cut 9 circles. Is it possible to do it only once, like cut it in once and
Yeah, it's possible. But I did that way to be more, how you say, to present more, to be more easy, because I don't know the level of everybody that are here, so I decided to do this way. But yeah, it's possible to do this way in one piece.
Okay, thank you. Any other questions for Pedro? Okay, I cannot see any hands raising, so once again, thank you very much for the presentation. Big round of applause, guys.